this session is diagnostic tips and tricks for Windows Store applications using Visual Studio 2012. So if you want to see something else, you might not want to be here. So my name is Brad Sullivan. I'm coming to you here from Redmond, Washington, where I work on the Visual Studio team at Microsoft. If you have any, follow-ups that you think of after this presentation, you can feel free to email me at Microsoft. It's my email address is brads@microsoft.com. So within the Visual Studio team, I work on what we call the Diagnostics team. So the Diagnostics team owns the Visual Studio debugger, the performance profiling tools, and IntelliTrace. More specifically, within the Diagnostics team, I'm the program manager for the Visual Studio debugger. So that's what I spend all of my days on. Over the past couple years, I spent a ton of time just getting very basic debugging of Windows Store applications up and going. Just from the very beginning of when the OS itself could barely launch the apps themselves. So I'm going to talk to you today about some tricks you can do to help you if you are developing these Windows Store applications, how you can better find and fix your problems in them. So I'm going to essentially go through 6 things today, and each of them will have at least one demo. So first, I'm going to talk about mixed language debugging. Windows Store applications can be written in VB or C#. They can be written in native C++, or they can be written in JavaScript. A lot of apps are actually using more than one of those. So I'll talk a bit about that. Talk about what contracts are and how to debug those. Talk about debugging background tasks. There's another talk tomorrow that goes much more in depth on background tasks. If you want to learn more about those besides just how to debug them, there is another talk available. An interesting topic that we ended up getting a lot of customer feedback about was how to debug installed applications without a Visual Studio project. So there's a lot of scenarios where you might want to do that. I'm going to talk about one thing that is very specific to JavaScript, which is the JavaScript Memory Analyzer. And then I'll show you a really dirty trick that you can do in C++ to help you find some bugs more easily. I usually like to keep the ugliest tips and trick to be last. Okay, so before I demo anything on the mixed debugging, I first want to talk about an update that we made for Visual Studio 2012. As you may have seen, if you use Visual Studio 2012, you occasionally get some toast that pops up in the bottom that says, hey, an update is available for Visual Studio. So far we've shipped, there's been a few pieces that have shipped that way, but we have also shipped one major update that went out in November. And there is another update, and that was update 1. There's another update, update 2, that is coming out reasonably soon and is available in CTP form. So one of the takeaways is that in Visual Studio 2012, we are continuing to add value through these updates. So one of the features that we shipped there was actually the native managed debugging for store apps. This really, it doesn't look or feel anything different than mixed native managed debugging for classic apps or for desktop apps, but now it just works. So there were a lot of things that were really missing in the RTM release. So one was remote debugging support. It wasn't really there. But we moved the mixed native managed debugging to a new layer that allows you to connect to a remote device and do your debugging that way. There is a caveat there that one does not actually work if the remote device is an ARM device, and that has to do with a limitation in the CLR where it doesn't support that yet. Maybe most useful is that native visualization. Before, what you would see is essentially just when you were looking at a WinRT object, say in the watch window of Visual Studio, you would see something not that useful like COM object. Now we have full parity with native-only debugging, where you can see any of the objects that we can normally visualize while you're native managed debugging. Finally, we added reliable stepping. So if you are stepping between the native managed boundaries, you're not landing in random goo code as you might have been before. So that so really it just looks and feels like it works. Now, as far as a tip and trick, let's say that you have an application that uses native code and JavaScript code. Now, when you're going to configure that application for debugging, you essentially have two options right now. One is you can choose native only, or you could choose script only. But what if you want to do both? We don't support doing both at the same time, but we kind of do. And so I'll show you how you can get that working. So first thing I'm going to do is I'm going to switch to Visual Studio. And here I have an application called Scribtionary. And this is primarily a JavaScript app, but it does use a WinRT component that is in C++. So here I'm in logic.js. You can see that's a JavaScript file. And here's scribtionary.cpp, and you can see that that is a native file. If I go to the project properties, go to debugging, I can see that it's set to script only. So I'm going to go ahead and debug this, and you can see that I'm hitting that JavaScript breakpoint. Now I'm going to just quickly show you what happens if you switch to native only. Again, although my font size has shrunk, you can see that I'm hitting now a native breakpoint. So that's kind of a pain in the butt if you have to start debugging and stop debugging every time you want to switch between the two. So what you can do is you can, in Visual Studio, switch this to script-only debugging, and then start. Now, let's actually just continue that. Now, what I'm going to do is open up a second instance of Visual Studio. So you can see in this version of Visual Studio, there's no solution open. I have, however, opened a little bit of switching craziness going on there. I have, however, opened up a source file by itself without a project, just through file open, and set some breakpoints in it. Now, in this separate instance of Visual Studio, I'm going to go debug, attach to process. And this is a JavaScript hosted app. It lives in WWA host. And naturally, what happens in WWA host, if this is on auto, it's going to choose script code. But I'm going to manually override it, and I'm going to choose native code. And when I do that, now I am debugging the application with 2 copies of Visual Studio at once. And I can hit this JavaScript breakpoint. But when I continue from here, by hitting F5, I've switched automatically. I brought the new the second instance of Visual Studio into focus, and I stopped at a breakpoint there. So by that sense, I can debug both at once without having to restart the app. There are some caveats here. So it's not true mixed mode debugging, so you can't, for example, view mixed call stacks or anything like that. But you can do this with the multiple instances. You also cannot try to debug the JavaScript while you're stopped at the native breakpoint. The reason for that is when you're stopped at a native breakpoint, all of the threads in your application are actually halted. And so JavaScript, on the other hand, requires threads in the process to run while it's debugging. So it's going to hang on you if you try to do that. But as long as you're careful, you can do this by yourself. Okay, so the next thing that I wanted to talk about was contract debugging. So Windows 8 store applications are sandboxed. And what that means is there's not there's a very limited way that different applications can talk to each other. But part of the infrastructure that the Windows team provides here is called contracts. So contracts, the two ones that are the most obvious, they come up right on the right-hand side of your screen when you go to the upper right corner, are the search and share contracts. So you can be in an app, and then you can select some content from that app, and then do a search using your secondary app. So what's the challenge there when it comes to debugging? It's not the same if you are writing an app that implements a contract. If your app knows how to share, for example, it's not just like launching your app. There's a specific entry point that it's going through, and you can't just launch under that entry point. So what do? Can you attach the debugger instead? Well, no, that doesn't really work either, because what happens is if you try to attach, you could end up missing some of your code as it executes too quickly before you can react and attach. So what do you do instead? So I'm going to switch back to Visual Studio. I'm going to get out of this app. And I'm going to open a different project here. Oops, still debugging. There it goes. All right, so now I'm going to do this share source. So this is a C# app. So the project properties on this app look a little bit different from the previous app that I showed you, which was a JavaScript app. And that's what I have open right here. So if you go up to the solution level and you click the solution level properties, what you can do is select under startup project, select multiple startup projects. And in my solution here, I have a share source app and a share target app. So one scenario might be that you want to debug both of them. So to debug both of them, you want them to both say start there. Now, my share target, I don't actually want to launch because I just want to enter it through the natural way that a contract gets launched. So I'm going to go to the project properties and select this checkbox here, which says do not launch, but debug my code when it starts. So that's what it looks like on a C# project, and on a JavaScript or C++ project, it'll just say launch, yes or no. The C# version is a little bit more verbose. So okay, let's see what happens when I F5 this. Okay, I'm going to, this is just an app that allows you to share various things. So I'm going to share a link. And when I say share, I'm going to share it to my other app, which is the share target C# sample. Now, because I had set it to, I had set that app to actually not launch, but debug when it starts, I automatically attached to that app and started debugging it, and I hit that breakpoint. So if I go look at my Windows here, just give a quick look at the processes window. You can see that even though I F5'd one app, I'm now debugging two. So let's stop debugging that, and let's go back to the solution properties. And now, instead of debugging both as a startup, I'm not even going to launch the source, which was the app that I actually started. So this time, it looks like I'm not actually starting anything. But I'm going to start debugging, and you can see that my Visual Studio IDE is jumping into debug mode. So now what I can do is I can go to Internet Explorer, and I can just do something more natural. Because when you're testing your app, you don't want to just test it through your own test harness that you brought up, but you want to do it through a real-world scenario. And so IE has the ability to share links. So I'm in IE, and I say share, and I can share it to my C# target, and boom, once again, I'm able to debug that. Okay. What's the takeaways for contract debugging? You want to configure the app to debug without launch in the project properties. You want to F5 the app and then invoke your application manually through the contract, and then you can debug any issues that are happening in the contract. All right. Somewhat similarly to contract debugging, there are some tricks to getting background task debugging to work. So background tasks are essentially tasks that run in the background that respond to specific triggers. Some of these triggers can be a lot harder than others to trigger manually. So for example, your app might have a maintenance trigger that fires after 8 hours. So it'd be kind of tough to just sit around for 8 hours and wait for that to trigger just so that you can debug that part of your code. So what we do is we give you a way to manually trigger these, and I can show you how you do that. So I'm going to once again switch projects. Okay, and in this project, I have a background task, and the way background tasks work is in your app, in the main part of your application, you register for a background task, and so I can. This app just allows me to register and unregister those background tasks. In a lot of other apps, you wouldn't have such a straightforward UI that says register, unregister, but you would just do it like, let's say when the user signed up for an alert or something like that and configured it. So now I have my background task configured, and there's a toolbar that is up by default in some profiles in Visual Studio, but not all profiles. and it's called the debug location toolbar. And that's this one right here that says process. If it's not visible, you can go view, view toolbars, and then debug location. And that's how you toggle that to be visible or not. From the debug location toolbar, you can choose a process. And then next to that process, you have a drop-down that allows you to take actions on that process. And so what it does, it'll enumerate all of the background tasks in the app that you are debugging and give them to you as triggers. So these strings here, servicing complete background task, sample background task, these are actually strings that you provided in your code when you were developing the app. So I'm going to trigger the sample background task. Oh, it looks like somehow. Oh, there we go. It took 2 tries for some reason. There's a little demo daemon striking there. So you can see that now I'm inside my background task, and I can, I can step through that and debug anything as I normally would. So if you don't have the app around, so if you don't have that app around that for registering and unregistering, you can actually do the same thing that you did in contract debugging, which is check this box, do not launch, but debug when my code starts. So even though the app isn't starting, because in a previous time that the app ran, it registered the task, the background task, it still shows up as registered. So after I've F5, you can see that I'm actually not debugging anything right now. I've just set it into debug mode. But when I trigger the background task, I've hit the breakpoints, and I've automatically started debugging this background task host that my task was hosted in. Okay. So the takeaways from that is you trigger the background tasks from the debug location toolbar. You can trigger tasks on apps that are not running. You just set them to debug without launching first. And you can trigger tasks that do not require a payload. So essentially, if you had a background task that was something like, send an SMS message, that's not something that you can trigger through that UI. Instead, you would need to manually just send that message to your device. Okay, so next thing I'm going to show is debugging without a project. So there's several reasons why you might be using Visual Studio, but you might not have a project. This could be that you do not have the necessary permissions to have that project. It could just be a matter of convenience where you don't necessarily have Visual Studio or on the machine where you want to debug, or the way your engineering system is set up, you normally build and deploy outside of VS. Attaching to process is particularly a pain for WWAs, for Windows Web Applications. And one of the reasons for that is because when you just launch a WWA, what it does is it'll JIT the JavaScript code that's running in there. And when you start JITting that code, it becomes undebuggable. And so if you just launched it as you normally would and then attached to it, it wouldn't really work. Instead, you would have to set a bunch of manual configurations and so that it wasn't JITting when it launched. But if you're going to do that, then you might as well do what I show you, which is much simpler anyway. So for this example, I am going to go back to this instance of Visual Studio that has no projects launched. And I'm going to show you a feature that's available under the debug menu, which is called Debug Installed App Package. Now, what installed debugged app package does is first it enumerates all of the applications that are on your machine, and it allows you to select them. Then allows you to select which code type you want to debug. So, for example, this camera capture UI C# sample. I would choose managed only. As you move through the different apps on your machine, you can see that the default code type that it's picking is changing. So it tries to automatically detect what that is. The other thing that you can do in this dialog is, as you can see in this top drop down, we're currently looking at the local machine. But if I had the remote debugger installed and running on a different machine, I could actually just connect to that as well. I don't have a second machine here, so I'm just going to show you doing it locally. So I am going to show you this camera capture UI. And so all I do is hit start from here. I've already got some source code open for that app in Visual Studio. So I'm going to start. Okay. Oh, and I clicked capture photo, and I get right to my breakpoint. So let's see. Okay. I was going to try to take a picture of the audience during this demo, but I think that my camera is, well, no, maybe it will work. All right. So hopefully I don't unplug it by accident, but I need some proof to my manager that I was here and actually gave my talk and everything. So I'm going to take a picture of me with the audience. Oh, there we go. All right. So now I have that. Awesome. So this feature actually has another cool usage that I will show you as well. So let's say, I'm going to stop debugging that app. Let's say I was instead debugging a JavaScript app. And who am I going to pick on today? I'm going to pick on the Bing Finance app. So the Big Finance app, I don't actually have any source code for. And I'm going to use this feature down here, which says do not launch, that says stop at first statement. This do not launch is the same as that other feature that I mentioned. So if you want to do contract debugging or background task debugging, you could. But I'm going to do stop at first statement. So I'm going to go ahead and do that. And since this is JavaScript, I can just start loading up the documents right away. And I can step through this. And as I step through, you can see I can pick up more and more of the source. And then if I wanted to, I could go ahead and start setting breakpoints on those source files and everything, and debug apps that are just on the machine. So if you're in a support role for WWA, you don't even need to have the source or symbols available to you. You can just use this feature and figure out what's going in the app, wrong in the app. Of course, if the JavaScript source code has been minified or anything, then that wouldn't work. Okay, So the takeaways there are that you want to use the debug installed app package feature to do this without a project. It works both locally and remotely, and you can automatically stop at the first line of JavaScript code so that you can load up any documents or anything like that you want to do. Okay. So the next thing I want to talk to you about is the JavaScript memory profiler. So this will be the second time I mentioned that we've continued to add features into the updates of Visual Studio. So this is a tool that shipped again in update 1 of Visual Studio 2012. And it's designed to help you solve memory problems in your JavaScript code. With the Windows web applications, it sort of introduced a new style of writing JavaScript code, and so memory usage is something that you've had to worry about a lot more than necessarily just something in a browser, especially if you have something like a leak that's going to build up over time. So JavaScript is a garbage collected language. So what is a leak in a garbage collected language? Well, a leak is essentially, in that case, just something that is still referenced, but unintentionally. So it's going to keep living on forever. All right. So I'm going to go ahead, and I'm actually going to do 2 different demos with this tool. So first, I'm going to show you what happens when you have how do you solve a problem where you just have unnecessarily high memory usage. So I'm going to open up a project. Oops. Sometimes this switches apps on me, and I don't want it to. Okay, so I have an app here. It's called MyPond, and I can show you what it does. So first, I'm just going to debug it. Not even going to do anything. So this is just an app where you can select a pond, and if you click on the pond, you can create some ripples. And these ripples are happening very slowly on this display, but you can see them right over there. Yep, they're happening. Okay. So, all right. So I'm going to exit that, and let's say that in my MyPond app, I've been getting reports that this guy is a memory hog. So how do I try to address that? So I'm going to go back to the debug menu. And I'm going to say JavaScript memory analysis, and that will give me a few options. So you can try to attach. You can use that same launch installed app package UI that I showed you before, or if you are already in your application, you can just say launch starter project. So I'm going to just launch the starter project. And so all I've done at this point is launch the project, and it's new. And I've entered this view where I can see what my memory usage is, and you can see there's an option here to take a heap snapshot. So what does it mean, take a heap snapshot? While I am doing some monitoring in real time, I'm not gathering a whole lot of data. But when I hit this take heap snapshot button, it's going to collect all the information from the heap for that one point in time. So I'm going to go ahead and do that. And you can see a summary of what's there. So I have a 31.67 megabyte heap and over 4,000 objects. The number of objects doesn't really bother me, but all I have is like a black screen with 6 little images on it. Why would that possibly take 31.67 megabytes of heap? So I'm going to dig into that further. So I'm going to click on that. And what this does is it brings me into a view where I can see what's actually in my heap. So it gives me a few different views. The default one is called the Dominators view. What the Dominators view is, it's showing me essentially what are the biggest things here in my heap. And if I'm just using, if I'm just trying to solve the type of problem where why am I using too much memory, that might actually be the best view for me. You can also switch to a view that will sort of group it by types. Sometimes that is useful, and then you get a filter control as well. So one thing that I notice almost immediately when I'm in this Dominators view is I have a bunch of images here that are quite large. So I have an image here, and this is 7.91 megabytes. I have another image here that's 5.9, 3.91. Why are my images so large? So, so this view makes me think that, somehow I'm retaining too much there. So now I'm going to go ahead and take a look at my code. So I'm going to stop my my memory view and take a look at my code. So let's see what has images. That was my home page, and I can see that. Oh, I'm just using that entire image, which might be too big, especially since I'm showing essentially what are just thumbnails. So I'm going to copy from this code snippet over here, where I'm already, instead of just using the entire image, processing it as a thumbnail. Get rid of the old way of doing that. Okay. Now let's see what happens when I launch it. So I'm going to start JavaScript memory analysis. Launch starter project. Okay, this was all I did last time. So let's see how I'm doing versus then. So last time I was at 30-something megabytes. Okay, now I'm at 1.99. So that seems much more reasonable, and so I'm pretty happy about that. But so that solved one problem. But now I'm going to continue to take a look at this and see what happens. So I'm going to click on this Pebbles. I'm going to start a ripple. The ripples are happening faster now. That could be because of the memory usage. And then I'm going to go back here. So I essentially took a round trip there. So, but it looks like my memory, based on this graph, has gone up a decent amount. So I'm going to take a snapshot and say, oh, okay, I went up by 15 megs. Well, maybe that's a one-time cache. Maybe that's okay, and then the next time I do it, I won't have that increase. It's just a one-time cost for performance reasons. So let's try it again. Let's go back here, make some ripples, and go back to the main screen. All right. Now I'm going to take a snapshot again. Ooh, it still went up a bunch. Not quite as much as last time, so maybe there was some legitimate caching there, but I definitely shouldn't go up by another 11.4 megs. So now that I have multiple snapshots, what this allows me to do is, since it's giving me these diffs in terms of heap size since the last snapshot, I can actually click on those diffs, and it generates this diff view. Now, this is a good time to talk about what is size and what is retained size. So size is just how large is the object in memory. That's the easy one. So retained size is the more difficult to one to understand, but probably the more useful in actually determining what the cause of your memory leak is. So it's the amount of memory that the object is preventing the garbage collector from reclaiming. So this is the size of the object plus the size of all referenced objects that the current object is the only parent of in the memory graph. So sometimes that word description isn't that helpful. So let's say that this diagram here is what your memory looks like. So those are the sizes of each of those items. So what do people think the retained size of object A is? Feel free to shout it out if you want. So some people said 600, some people said 700. The correct answer is 600. It's because the retained size is the object itself plus all of the objects where it is the sole parent. So that would be object A plus object B. Object D is not included because if you got rid of object A, object D would still remain in memory because object C is holding a reference to it. So the rest of these are fairly straightforward. Object B, object C, and object D, their retained size is just their size. So let's go back to Visual Studio here. And in my diff view, oops, there we go. I can see that I have a ripple at the top, and its retained size is 11.25 megs, so that's pretty high. Now if I click on ripple, I get another interesting view, which is this reference graph. So now I can go and I can look at what is keeping this ripple alive. And I can see that I actually have a callback that is keeping it alive. So let's look at the code. Oh, yep. So I do have a request animation frame here. And then that is going to end up keeping this alive because I have a callback that I am in nowhere here canceling. So now I'm going to fix that. I'm going to stop profiling this old one. Okay. So now I'm adding this this code here that adds a cancellation, adds a cancel to this callback. Let's go back to pool to add that there. And now, not quite done yet. Now what I need to do is I need to go back to my my pond. And so that I can call this cancellation, what I have to do is I need to change the scope of water here. So I'm going to move water up over here, and then here we go. Then on my unload, I should be able to call water.cancel. All right. So now let's see how that works. So I'm going to debug. Start the JavaScript analysis again. Let's see how I'm doing. Okay, 6.1 megs. That's pretty good. It's much better than last time. Let's see what happens if I do that again. Is it the same? It is slightly smaller. So there was a little bit of cleanup in there. So I have effectively fixed my memory leak by using this new tool. Okay. So finally, I'm going to show you the dirty trick, which I've been saving for last. So when you're writing Windows Store apps, you might have noticed that in your XAML apps in particular, and I would say more so in C++ than in C# or Manage, it can be real tough to find the real error that's happening. Turning on first chance exceptions can help, but a lot of times that creates a lot more noise than it does, and that noise slows you down. The async patterns that are so prevalent in Windows 8 apps can make this a lot worse. They can make it so that these exceptions are getting handled and rethrown so many times that you're losing really the original context of the error, if you're even getting that error at all. So I'm going to show you a trick that you can use in C++ in particular to solve some of your problems. So let's open this one here called native exception. And the first thing I'm going to do is make sure I've got my exception setting. So right now I just have these all, let me clear that. This is all now the standard settings for exceptions. So if I just, this is a very, very basic app. If I just start debugging it in native, it's taking a little while to build. Okay, now I click on this. All right, what do I get? This is my error. Unhandled exception at blah. In native exception.exe, an invalid parameter was passed to a function that considers invalid parameters fatal. Well, that's sort of helpful, but what function was that? I don't know. This doesn't give me any more information here. So if I break in, where am I stopped? I'm stopped in task collection.cpp, which is part of the runtime. It's not all that interesting. Let's see if I look at my call stack, what do I find? I don't find anything interesting at all. Looks like this is all stuff in the concurrency runtime. What about this lambda here? Is that mine? No, that's in ppltasks.h. So again, that's not very helpful. So I got this exception, and I have no idea what in my code actually failed. So what I'm going to do is I'm going to stop debugging, and I'm going to go to my exception settings. I'm going to open Win32 exceptions, and I'm going to select this new exception type that's called WinRT originate error. Now, a WinRT originate error is an exception that is essentially always handled. It is just part of the messaging process of Windows itself when errors go wrong. So, what happens if I say I'm going to break at first chance of those. What happens? Hooray! So I've stopped at a first chance exception of this type of WinRT originate error. Although it doesn't really tell me why. It just says that, it just tells me the basic information that if there's a handler for the exception, it can be safely continued. Well, okay, that doesn't help me. But on the other hand, it does take me to my code. So I can tell that there's something going on here on this line that is broken. Now here's where the real dirty part of this trick comes in. So I'm going to break again on that same exception at that same spot. And now I know the line of code, but now I'm going to do something wacky. I'm going to take this third parameter of the exception. I'm going to copy it to the clipboard, break into the debugger, and now I'm going to go to the memory window. Just not normally the window you want to go to, and I'm going to inspect that parameter, and I can find a secret string that tells me, that tells me more about the issue. So if you read this part of the memory window here, you can see the specified path, C users, Brad's, blah, 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 contains one or more invalid characters. And so if you look closely at the string, you can find the invalid character, and it is indeed this / right here. So if you ever really want to impress your friends when they have a broken C++ app, nobody will know how you figured out how to do that. Okay. So the way you set that up is you just stop on the originate error exception and use the memory window on the third parameter to find the secret string that they can help you with your message. Okay, so that finishes up the demos I'm going to show. There are some related sessions if you're interested that you might want to go to. Jeff will be presenting a more in-depth talk on background tasks tomorrow. And that's something that I went over briefly here, only on the debugging side, not really on the development side. And then I also have another talk tomorrow, which is diagnosing issues in your ASP.NET applications in production. So that is also tomorrow morning if you're interested in that. If you want to follow more about the developments of diagnostics in Visual Studio, we do have a blog. It is the Visual Studio ALM blog. There's a few other things in there as well, like updates to TFS. But essentially, every diagnostics feature that we develop and release, even when it's in preview, we will talk about on that blog. And so it's a good way to keep up on the latest. Finally, one of the things, whenever I'm meeting people who use Visual Studio, I always get feature requests. And so we have a great way, and I love hearing the feature requests in person. Actually, if you find me at the Ask the Experts after this and want to tell me the 10 features you want the most, I'm always super happy to hear it. But we actually have a site now where you can submit feature requests and vote on them. And while I can't promise you any features in our next release, I can tell you that the voting really matters here, and a lot of the things that are really up there in the votes are currently under development. Okay, with that, I want to open it up to Q&A if anybody has any questions that they would like to ask me about debugging or diagnosing Win8 apps, or even just debugging in general, I'll be happy to answer them. Yes.
The memory usage thingy, can we expect that for C#?
So the question was the memory usage tool that I showed. Can we expect that for C# as well? So in C#, there are a couple tools available now that do some similar things. One is called PerfView, and that is released by Microsoft. It's not integrated into VS yet, but it was actually developed by people within the VS organization. And then I can't make any promises about future features, but I can tell you that you're not the only one who has requested something more integrated into VS for managed memory. Are there more questions? Okay, well, that was a easy crowd then. If you don't have a lot of questions, if you want to find me down here and ask me something private, or at the Ask the Experts, I'll be around. Thanks.